I just see here, I'm starting off with these technical obsessions. I just got this computer and this thing, I don't know how to get rid of it permanently, but there we go. Great. I'm going to some degree, I'm going to pick up where the Autodesk presentation left off and have a look at what it looks like when that technology is applied in fairly conventional projects. Just a bit of an introduction. Gary Technology, it's about the process of design and construction. We help to improve the process. And it specializes in scale and complexity, bringing clarity, and the word I've added, coordination. This is part of the conversation in a way that we're all involved in, which is global construction industry transformation, and we'll talk more about that. This is a quote from Frank Gehry's partner, Jim Glint. A conclusion he came to over the years. If architects don't take back full responsibility for design and construction, someone else will. And we're seeing that in the way Gary Technologies is working. Having said that, architects are still in those positions as trained architects, just not as organizations. Who is GT? A consulting technology development and research firm. It's a spin-off from Gary Partners Architects in 2002. But it's founded on 15 years of experience of digital project delivery in the Gary office. It consists of 60 engineers and computer scientists. Office in LA, New York, Paris, and Hong Kong, and that's where I've come from. So GT is informed by 15 years of building information modeling, which is what they were effectively doing, using CATIA and digital project at Gary Partners. CATIA is another software solution, and it was interesting to Gary's in the days before Revit existed. Gary Technologies and Gary Partners Architects BIM examples. This was the Disney concert hall where they started something that is going to be the main thing I talk about, which is MEP and structural coordination. So we're getting down to nuts and bolts here in a way. GT offers process knowledge, people to build more effectively. Best practices, experienced staff, best breed of technologies, project-based delivery. Okay, this technology for me splits into two categories. The one is using it to design and innovate, and I'll show a couple of examples of that quickly, just as an introduction to Gary Technologies worldwide. But what I've been doing in Hong Kong is going back a step and looking at enhanced efficiency in the process. So just briefly, some examples. My colleague Cristiano worked on these optimizations in Zaha's office, and the one on the lower right is a chap who's working in Hong Kong. I would point out, do I get to have a laser pointer? Laser pointer. Is it a laser pointer? Yeah, all right. So these are just snippets of how the technology can work in design. I'm not going to go into it in detail, but things like when you have defining curves and there are interrelationships of a sophisticated sequence of parts, you can just move the curve up and down, and there is the emergence of knowledge embedded in these other elements so that you can make global changes. And SOM in New York is also using this kind of technology. This is an example of the integration of a program called Ecotect, which is a globally kind of recognized energy analysis software. And the point of this is to show that we have the interoperability of many of these tools. So there's energy analysis here, daylight analysis, direct gain, peak solar gain, and they are directly linked to the geometry of the project. So you get the emergence of engineering simulation and analysis informing design. I'm not saying that everyone is going to suddenly do all of their design from engineering, but it's there, and we'll look at that. It's a tool that's there, and we'll look at that. just touching on some projects in the world. This is not just the SOM tower, but the entire World Trade Center site, including all the sewers, water pipes, trains, new towers, and everything the building information model is being managed by GT. And a theater in New York. And this wasn't put in specifically for this presentation. SOM is working on this project in Hyderabad where they're doing that using energy analysis to generate buildings. I'm not here to necessarily talk about the architecture. I'm talking more about the process. And these facade treatments were arrived at using, to some degree, tools that were informed directly from energy analysis. In Dubai, a large project, the front of it here is this project by Asymptote, and they brought us in to fully automate the way that form is designed and managed so that they can use it as a kind of toy to tweak it and optimize it. Okay, this is the main thing that I want to talk about. This is the first time I've actually just put the numbers 10 to 30% on. I don't want to talk too much about the numbers 10 to 30%, but it's kind of widely recognized that the construction industry is very inefficient worldwide. Doesn't matter which country. And as it's a 3 trillion industry, it's 3 times the size of the car industry. So it's a very significant effect on all of us. And so if we can put into place technology and working methods to save 10 to 30%, it's a big start for some of the objectives that we all have. So when I put this back in, I've taken it out before, but when I called up to find out who I had to talk to get permission to use this slide, I've been using it for a while, and I thought, well, let's get permission. Turns out it was from the Ford Motor Company in the 90s, and they had realized that 70% of the influence on, these are statistics from the Ford Motor Company, 70% of how the project went was determined in the first 5%, and the others were less significant. And that, we think, applies to construction. So we don't have too many slides with risks, but these are essentially figures from Psyche. Martin Fisher at Stanford University spends a lot of time measuring the construction industry. And so these are numbers, statistics from 32 large BIM projects in the United States using all kinds of tools. And the numbers are conservative, I found. You'll see that on the centerpiece project that I'm going to show you this afternoon. 5 to 10 times return on investment. So every dollar you spend on BIM, whoever is paying for it gets 10 back. The most important one is 10% cost of construction, which we are achieving through clash detection alone, and an additional 20% savings through construction process modeling, which I'll show you. A few other things worth mentioning. The numbers are conservative, and one example is I've seen projects that have 18,000 RFIs, 18,000 request for information forms. On the 70-story tower I'm going to show you, there's 140. So it's a complete change in the way of working because these RFIs have a cost to manage. Our partners, people we work with in Hong Kong and in China, I will say that the process has largely been owner-driven. The owner is going to get that 10%. And in this case, one of the owners is Swire Properties. And these are, roughly speaking, their ecosystem of working partners in Hong Kong. Okay, this slide was given to me by Swire. 40% of waste in Hong Kong comes from construction. And the owners are saying, well, we paid for this. Wouldn't it be great if we didn't have to? And that's largely the way I've been working with applying the technology in Hong Kong, as opposed to the other